Hello dear students, today we are going to learn application of phase rule. The first one is water system. So in this topic we are going to study 2 points. One is significance of curves, second one is significance of area, and third one is triple point. So here the first one is significance of curve. So this is the phase diagram of water system. So here the first curve we consider OA curve. This is OA curve. So here it represents the equilibrium between liquid water and vapor water. So this curve is known as vapor pressure curve of water. So when we apply the phase rule, so our phase rule is F is equal to C minus P plus 2. F is degree of freedom, C is the component, P is the phase. So here component is 1, means water, and phases are 2. One is water, another one is vapor. So our degree of freedom is equal to 1. So we will call it as univariant. So there is only one variable along this curve OA, either temperature or pressure. So composition remains constant. So this is one component system. So when you apply the Clausius-Clapeyron equation, which gives the variation of vapor pressure with respect to temperature. So here we will study. So this is the Clausius-Clapeyron equation. dP by dt is equal to delta Hv by T into Vg minus Vl. So here delta Hv is nothing but molar heat of vaporization. Correct? So next second curve is OB curve. So OB curve indicates, this is the OB curve indicates equilibrium between ice and water vapor. So it indicates the equilibrium between ice, means solid water, and vapor water. So this is called as, this curve is called as sublimation curve of ice. So when we apply the phase rule, we will get again 1, means composition is same, H2O same composition, phases are different, one is solid phase, another one is vapor phase. So then we will get degree of freedom is 1. So here when we apply Clausius-Clapeyron equation for this OB curve, we will get dP by dt is equal to delta Hs divided by T into Vg minus Ps. dP by dt means variation of pressure with respect to molar heat of sublimation. So next curve is OC curve. This is OC curve. So this indicates equilibrium between ice and water. So again this is one component system. Degree of freedom is 1 because composition is same, H2O, phases are different, one is solid phase, another one is liquid phase. So this is also one component system, or we can also call it as univariant system along this curve. So this curve is called as fusion curve of ice. Correct? So when we apply Clausius-Clapeyron equation, we will get dP by dt is equal to delta Hf divided by T into Vl minus Vs. So if Vs is greater than V1, so therefore what happens, the equation possesses a negative sign, so we can write it as dP by dt is equal to minus delta Hf divided by T into Vl minus Vs. Correct? So this is a delta Hf, molar heat of fusion here. So next second point is, these are 3 curve, and second one is triple point. So this is point, triple point O. Here 3 curves are meet each other. One is OA curve, second one is OB curve, and third one is OC curve. OA curves indicates equilibrium between liquid water and vapor water. OB curve indicates equilibrium between solid water and vapor water, and OC curve indicates equilibrium between solid water means ice and water. So what happened? These curves meet each other at this point O. So these all three phases are in equilibrium. Ice is equilibrium with liquid water, and this liquid water is equilibrium with vapor water. So here when we apply the degree of freedom, F is equal to C minus P plus 2. Composition is same, water only, but phases are different. Here three phases, one is solid, one is liquid, another one is vapor. So here we will get 0. Correct? This is triple point. So we can define it as at the point three phases are in equilibrium, the degree of freedom is 0. Therefore, system becomes invariant. That point is known as a triple point. Correct? This is triple point. And last part is significance of area. So first one is significance of curves. Second one is triple point. And last one is significance of individual area. So here first one is OA curve. This OA curve indicates the equilibrium between liquid water and vapor water. Correct? Then at the point X, if pressure is increased and temperature is kept constant, at a constant temperature at point X, pressure is increased, then what happens? Then equilibrium will shift towards the left side. Equilibrium shift towards the left side. Then more and more vapors will, here the more and more vapors will convert as a liquid. So vapors will condense in a liquid state. Therefore, this change is represented by XA. This change is represented by XA. At point A, at point A, water is present in the liquid state. Again, here from point X, if pressure is kept constant, now pressure is kept constant and temperature is decreased. Here, this is the temperature. So temperature is decreased. What happened? Then vapor is converted to liquid state. So that is represented by XB. Correct? So here B point represent liquid phase. Therefore, area occupied between OA and OC curve is due to liquid water. Again, at the point X, pressure is kept constant and temperature is increased. Temperature is increased, then the liquid water is converted to vapor. And if temperature is kept constant and pressure is decreased, then liquid is converted to the vapor. Therefore, area lying below the OA curve, the area lying below OA curve containing vapor water or water vapor. Understood? So the area between OC curve and OA curve is liquid water, and area lying below the OA curve is vapor. Similarly, OB curve indicates, here the OB curve indicates equilibrium between solid ice and vapor water, and at the point Y, if temperature is increased at a constant pressure or pressure is decreased at a constant temperature. So these two lines, YA dash and YB dash. So here what happened? The solid is converted to vapor water. So the area lying below the curve OB is water vapor. Therefore, the area occupied below the curve OB is due to vapor water. So, if pressure is increased at a constant temperature and temperature is decreased at a constant pressure. So, two possibilities. So, this one is YC dash and YD dash. So, here what happened? The water vapor is converted as solid ice. Water vapors are converted as solid ice. Therefore, area between the curve OB and OC curve is due to solid ice. So, this entire area is solid. So, in each area, this is one area and this is another and this one is another. So, here each area there is single phase. So, here vapor phase, here liquid phase and here what? Solid phase. So, here when you apply the phase rule for significance of area, when you apply the phase rule for this area, equation is F is equal to C minus P plus 2. C is composition is same, water, H2O, and P is the phases. So in each area there is only one phase, means phase is also 1. So then we will get degree of freedom is 1. So it means in significance of area, system is bivariant. Bivariant means there is only two variables, one is temperature and pressure. So this is significance of area. And one more point is there, metastable equilibrium. The curve AO here, the curve AO represents the equilibrium between liquid water and vapor water. If water is cooled below 0 degrees Celsius without separation of ice, so that water is called as supercooled water. If that supercooled water is equilibrium with vapor water, then that possibility is shown by the dotted line OA dash. That possibility line is OA dash. That metastable equilibrium is having high pressure than that of stable form. So that is metastable equilibrium. So this is metastable equilibrium OA dash.